Welcome back to the last video in this series. We are doing one more problem on compound probability, and we will have completed our course, which is pretty exciting, I think. So the definition of a dependent event or dependent events is second events whose probability depend on a first event. So this time, what happens on the first event matters, and it will affect what happens thereafter. And to show you how to do this, I have given you the example of a standard deck of cards. There are 52 cards in a standard deck with 4 suits, and that means your diamonds, hearts, clubs, and spades, the suits, that each have a king, a queen, a jack, 10, 9, 8, 7, 6, 5, 4, 3, 2, and an ace. So you have all of those cards in hearts, all of those in clubs, all of those in spades, and all of those in diamonds. What is the probability of drawing 4 face cards if you do not replace cards after a draw? And here is the key. You do not replace cards. So once you take the card out, you are not putting it back in the deck. That's what makes dependent. If you put it back in the deck, you would have an independent draw every time. But with dependent probability, each time you draw, you're taking away one of the options. And that's why the second event depends on the first one. Because without the first one, you can't get to the second one. What is the probability of drawing 4 face cards if you do not replace the cards after a draw? So we have to figure out what our face cards are. And those are any cards with faces on them. So that would be the king, the queen, and the jack. Those are your 3 that have faces, pictures of people. So we're not interested in these others. We're only interested in the face cards. So here's what you have to realize, and this is a little bit tricky. This gets a lot of folks. This is why I chose this example. So each of the 4 suits, diamonds, clubs, spades, and hearts, has 3 face cards. Because you have the jack of clubs, the jack of diamonds, all of them have, there's 1 in each suit. So we have to know that 3 times 4 is 12. So on my first draw, and let's do it, let's write it out, let's organize. The first draw, the second, we're going to draw 4 cards. The third, and the fourth. And then we have to rely on common sense here. So let's focus on the first one to start with. We know that in the deck there are 52 cards. And we know that on that first draw, when all the cards are still in there, 12 of them are faces. Because of this right here. So the first draw, my probability is 12 out of 52. Okay, in the second draw, how many cards were left in the deck? Remember, you took one of them out, so there are 51. And now we have 11 face cards, because we took one out in the first draw, we're assuming. Okay, in the third draw, there are 50 cards left because we took 2 away, and 10 of them are face cards. And then finally, in the last draw, the 4th card, we only have 49 in our deck, and only 9 of them are face cards. So we want to know the probability that this will happen, that we get a face card 4 times in a row. I won't bet on this one, guys. So let's multiply and see what we come up with. So the first fraction I'm going to multiply is 1252. 12 ABC 52 times 11 over 51 times 10 over 50 times 9 over 49. And we come up with a very weird fraction. It's okay. It's supposed to be weird because this is such an astronomically small chance. It's okay. You should come up with this fraction. Now, if they want you to leave it in fraction form, you've got it made. You've got this right here. You're done. But remember, if they want you to divide it, you would have to do this division. And I want you to do this because there's something I need to show you. When you do 99 divided by 54/145 equals, you get something incredibly odd looking. And this is one reason I chose this problem. I want you to see what this means. This is called scientific notation. And what it's saying is your calculator saying, whoa, I cannot handle that number. My little screen is not big enough to do this. So what you need to do to read scientific notation is right here. The negative 03 means to move the decimal 3 places, negative is left. Okay, so I'm going to take let me move this down just a hair because I don't want to lose any of my problem. Just going to bring him right here. So I'm going to pick up my decimal that's already sitting there and go 1, 2, 3 and drop it. So you have a 0, 0 and then that number. So your percentage of this happening is about 0.001. Actually, we would round that to a 2%. There is no way that I would bet money on that. That is less than a 1% chance. That's about as close to 0 as you can get. It's about as close to impossible. But it's not impossible. It could happen. And for those of you who play poker, I believe that's a pretty good hand. But I'm not sure because I don't play. Alrighty, guys. That is the end of the probability. It is also the end of the course. We have made it through to the end. I hope that you have enjoyed this course as much as I have. I've really enjoyed doing it. It is not easy material, so please don't hesitate to contact me if you have questions or if I can help you in any way. Remember, you have my contact information right there, back on the first page. Email is the best way, but the office number and the text number are both going to work. It just may take a little longer to get the answer. But I'm here to help you if you need me, and I hope to see you in another course. Thank you for joining me, and best of luck in your educational pursuits. Have a great day.